Hello and welcome everyone. So the point of these notes here is just to reinforce where our cost curves are coming from. They're being driven by our production technology. So I'm just going to build this up conceptually and then I'll do an example. And so ultimately I'm going to bring together our cost functions determined or defined in terms of output with the cost functions we're going to work with more typically in intermediate micro, which are defined over inputs. All right, so the beginning part. Suppose we have a firm. It's going to use L units of labor, K units of capital. We've got prices. W is like wage. R like rental rate of capital. Basically, this is the price of using labor, price of using capital. It's got to produce Q units of output. Well, so it's production technology. This is an F. This is kind of weird. This is just an F for production technology. F of LK is going to be the amount of output. The costs are going to be, well, the price of labor times the amount of labor plus the price of capital times the amount of capital. So this is my expenditure on labor. This is my expenditure on capital. Total gives me my costs. The additional output produced when we employ one more unit of labor. That's the marginal product of labor. Or if this is capital, marginal product of capital. So my MPL is going to be dFdL. My MPK is going to be dFdK. Right? This is just the marginal product of labor is the derivative of my production technology with respect to labor. Marginal product of capital is the derivative of the production technology with respect to capital. Now, if we assume capital is fixed, this is K fixed. This doesn't look like a K. It's a K. So this is upper bar here means it's fixed. So anytime you see whatever is the factor of production with line drawn up above it, then I'll indicate that to mean it's a fixed factor. That also tells us it's a short run problem. All right, so my production I'm going to get is actually, if capital is fixed, it doesn't mean I'm not using capital. It means the amount of capital is fixed at whatever K upper bar is. And I'm choosing to vary L. So how much output is produced when hiring one more unit of labor? That's a marginal product of labor question. What's the value of this additional output? That's a marginal revenue product question. Let's multiply my marginal product of labor by the market price. That gives me my value of the marginal product of labor. So if I use one additional worker hour or one additional machine, it's going to increase my output. That's my MPL or MPK. And then the value of that output if I multiply by the market price of the output. Remember, the price of the inputs were omega or wage and then R. Right? W and then R. All right, so what's the additional cost of obtaining the additional output? Well, capital's fixed, so it's just the cost of labor that we need to produce one more unit of output. So let's see, is it just wage? Is it just W? Well, W is the cost of labor. That's not necessarily the price of one output, right? When labor rises by one, we're going to incur another W for each labor. If we increase the labor hours by one, we're going to pay another wage for that hour, right? So if labor hours is 1, then wage is going to be 1 times W. If labor hours is 2, it's going to be 2 times W is our cost of labor, all right, or additional cost of labor. Employing one more unit of labor does not mean the firm gets exactly another unit of output. Unit of labor might make many units of output. So what we want is for the cost of labor, we want the cost of labor to produce just the first unit, the marginal product or the marginal cost of that first unit. All right, so increasing L gives us the cost, W. It gives us the marginal product, MPL. We can find the cost per unit, right? The cost per MPL. Cost per MPL is just going to be marginal cost. It's going to be wage divided by MPL. Cool. All right, so we have this nice relationship. Marginal cost is wage over MPL. This is driving home the idea that marginal costs, our costs, are coming from our production technology. It's our production technology that's determining my marginal product of labor, right? Because this is the derivative of my production technology with respect to L. All right, so looking at this, let's just kind of getting our bearings. The marginal cost is the wage divided by the marginal product. Suppose it takes 3 extra units of labor to get 1 more unit of input. The marginal product of labor would be 1/3. Or put differently, another 1 unit of labor gets the firm an additional 1/3 units of output. So the marginal product of labor would be 1/3. Now, if the wage is $10 per hour, the marginal cost of 1 more hour of labor is $30. So then the marginal cost of an additional unit of output, would be marginal cost is wage divided by MPL. We had this from up here. So the wage of 10 divided by 1 over 3. Now you see why I picked a fraction, right? It's $30, right? The marginal cost of that additional unit of output was $30 because it's 10 is our wage divided by marginal product of 1 unit of labor is 1/3. So my marginal cost is $30. If it takes 3 hours to get 1 unit of output and labor costs $10 an hour, marginal cost of the additional unit of output is $30. All right, so now let's bring this idea together with our production technology and build cost curves. So suppose we have this nice Cobb-Douglas production technology. This is like our scaling factor, so it's 2 times this L to the 1/2, K to the 1/2. Suppose wage is 1, rental rate of capital is 1. We're fixing capital at 64. Oh, that's a perfect square, so this means 64 to square root of 64 is 8, so that's nice. So we'll have 16 times L, the square root of L, that's this right down here. Anyway, so the fixed cost is what? Rental rate of capital 1 times the amount of capital, K. Fixed cost is $64. Average fixed cost is going to be 64 divided by output. Wait a second, now we've got average fixed cost defined in terms of Q, right? What about variable cost? What about average variable cost? What about marginal cost? Well, my production technology is going to be 2 to the L half, 64 to the half. All right, so Q is equal to 16 to the 1/2 power. Solving for L, I have Q divided by 16, that whole thing squared. This gives me my labor cost to get 6 units of output, or 16 to get Q units of output. This gives me my labor cost to get Q units of output. I'm distracted because I see that the visual of me is not keeping pace with what I'm saying, so I hope this video saves. Anyway, so if this is, so now we've got L defined in terms of Q. My variable cost of producing Q, V of C of Q, is going to be, well, wage times L, which is a function of Q. So my wage, which is 1 times L, which is Q over 16, that whole thing squared, gives me what? Q squared over 256 is my variable cost. My average variable cost, we got to divide that thing by Q, gives me Q over 256 as average variable cost. And my marginal cost, let's take the derivative of that. That's going to be Q over 128. That's just taking the derivative of 2Q over 256. It's going to be 2Q divided by 256, which is Q over 128. It's my marginal cost. What's my marginal product of labor? Well, my marginal product of labor, let's differentiate my production technology with respect to L. And I'm evaluating where capital is fixed at 64. And so we have, what, 16 times L to the half. If we take that derivative, it's going to be 1/2 times 16 is 8. L to the reduce the power by 1 is minus 1/2. So my MPL, marginal product of labor, is 8 times L to the minus 1/2. Great. Our marginal cost then is W over MPL. So my marginal cost is 1 over 8 times L to the minus 1/2, or square root of labor divided by 8. Well, wait a second. We already found our marginal cost. It was Q over 128. So what gives? How can it be Q over 128 and also L to the 1/2 over 8? Well, it turns out these are the same, right? So if I just equate Q over 128 to L to the square root of L over 8, and then solving, right? Cross multiplying and then solving, I'll get Q is equal to 16 L to the half, or Q is equal to 16 times the square root of L. And then sure enough, if we take a look at our production technology and evaluate where capital is fixed at 64, that's exactly our production technology. Q is equal to 16 times the square root of L. Indeed, the shape of our cost curves in terms of output are inherited directly from our production function. In terms of like these different ways of stating marginal cost, MC is equal to Q over 128 gives us the marginal cost at Q units of output. Marginal cost is equal to the square root of labor divided by 8 gives us the marginal cost at L star units of labor. Presumably, Q units of output requires L star units of labor, and vice versa. So anyway, this shows how we can relate our production technology and our cost curves. So we can see cost curves defined over outputs, our production technology is defined over inputs, and then we can get our marginal product, which is defined over inputs, so we can get our costs in terms of inputs or in terms of outputs. Indeed, it's our production technology given rise to the firm's costs. Anyway, I hope you enjoyed the video. I sure hope this video saves. I can see that this is out of sync with my my image of myself. But anyway, I'll see you next time.